Hello everyone, today is another video from the Element Lab, Learn Through Question, and this video is meant for the JC student. So for the JC student, if you are revising for your upcoming test, this video is for you. So today's video is on from an A-level question from 2018, which is on the chemical energetic definition. And this question is asking which equation corresponds to the enthalpy change stated in this case. And in this question here, they are talking about 4 different definitions. Now, before we take a look at the option, let me go through some of the things that you need to take note about the standard enthalpy change definition. Now, the definition usually we can split into 3 parts. The first part, we will ask ourselves whether the process itself, is it an energy change, a release, or absorb, depending on whether the reaction is exo, endo, or can be both. Number 2, then we will take a look at what is the reference substance that I'm referring to, the 1 mole. So 1 mole of a particular substance. And number 3, then we will discuss what is the process that is happening for each of the different definitions. Now, so let's take a look at the first definition on lattice energy. So lattice energy, the first thing we need to take note is that the process is actually exothermic. So therefore, energy release, number 1. Number 2 is with regards to 1 mole of solid ionic compound. In this case, is being formed from the third stage, the process, which is from its constituent gaseous ion. Now, if you take a look at the equation in option A, you realize that it indeed formed 1 mole of the aluminum oxide ionic compound, which is in the solid state. And if you realize also that you are forming it from the constituent gaseous ion, and you can see that the mole ratio has fit nicely. But you can see the problem with this question is option A, you realize there's a 2 in front, which doesn't make sense because we are not forming 2 moles of aluminum oxide, but only 1 mole. So that's why option A is definitely wrong. Now, let's take a look at option B, which is on neutralization. Neutralization is about, again, is energy release. It's an exothermic process. But for neutralization, it's all about forming 1 mole of water from an acid-base reaction. So if you take a look at this equation, the error that you can clearly see here is the fact that in this equation, there are 2 moles of water, which in this case is not correct. So by right, it should be 1 mole, and therefore the equation should be scaled accordingly. So we should put a half, this one should be 1, and there's a half of the sodium sulfate salt. So in this case, B is also up. Now, let's take a look at option C, which is on the enthalpy change of solution. Enthalpy change of solution can be exo or endo, therefore we usually write it as energy change. And it's all about the 1 mole of that particular substance being dissolved in a particular solvent. Dissolved in a solvent. So usually for us, a solvent we usually refer to is water. Now, so if you take a look at the equation, you can see that yes, indeed, we have 1 mole of the calcium chloride being dissolved. Alright, and we indeed see that it has split into its aqueous ions in this case. So therefore, option C is the answer. Now, why option D is not the answer is because formation is also again can be exo or endo, so therefore it's energy change. Number 2 is all about forming 1 mole of that particular compound from its constituent element is its a standard state in this case. At standard state. And you can clearly see in this case they want to form the sulfur dioxide gas, but again the ratio is not correct. This one should not be 8. It should actually be 1 mole of the SO2. Therefore, the equation should scale accordingly, and this one should be 1, while this one should be 1 over 8. And that's why option D is not correct. And that's it for today's video.